Good evening, all of you. We solved exercise 16.3 questions, the theory of which we have already discussed. Which of the following uh, cannot be a valid assignment of probabilities for outcomes of sample space omega 1 to omega 7? So, these are the outcomes, seven outcomes, and different probabilities are assigned. Okay, probabilities assigned means point 1. First probability of omega 1 is 0 0.1, 0 0.01, 0 0.05, 0.03. So here when you add, if you add this 0 0.1, 0.2, 0.3, 0.6, 0.7, 0.7, then 0 0.01, 0.5, 0.3, 0.1, if you add this all together you will get 0 0.1, 0 plus 1, 0.9. You will be getting the value as 1. Okay, value 1 you got, therefore it is valid statement. A is valid statement. B, and if you sum up 1 by 7, 1 by 7, 1 by 7, and in addition these outcomes are called equally likely outcomes. That is an example, that is why I mentioned here. All the outcomes are given equal probability, therefore it is called equally likely outcome if the assignment is like this. And 7 times 1 by 7, that means 1, total is equal to 1. So 1 by 7 plus 1 by 7 plus 1 by 7, 7 into 1 by 7 is equal to 1, total is equal to 1, therefore that is also a valid assignment. 0.1, 0.2, 0.3, 0.4, 0.7, 0.5, 0.6, and here itself you can see that two probabilities, when you sum up you will get 1.3 here. 0.6 plus 0.7 is 1.3. So that cannot be a valid assignment because it will be exceeding 1. Total will be exceeding 1. Okay. So total will be exceeding 1. Therefore, it cannot be a valid assignment of probability. So C is not a valid assignment. And here itself you can see minus probability is given. Probability cannot be a minus number. So minus number is assigned to a outcome. Therefore, it cannot be a valid assignment. And similarly you can see here because of minus 2 is also there, so negative probabilities cannot be. And here one probability is 15 by 14. See, 15 by 14, can it be a probability? No, because 15 by 14 is a number greater than 1. A probability of a particular number can be maximum 1, not more than 1. So this, because of this probability, we can say that this assignment is not a valid probability assignment. Now question number 2 is, a coin is tossed twice, what is the probability that at least one tail occurs? At least one tail occurs. So that is quite simple. Question number 2, sample space is in set H T TH TT. These are the outcomes. Okay. Now the question is, what is the probability that at least one tail occurs? At least one tail occurs means at least one tail. Here this is one outcome. This is one outcome. At least means one or more than one. That is TT is also one such outcome. So out of 4 we have 3 outcomes. So the required probability is 3 by 4. Understood? So 3 by 4 is the answer to question number 2. And question number 3, a die is thrown. A die is thrown. Find the probability of the following events. A die is thrown means total 6 outcomes will be there. Die means 1, 2, 3, 4, 5, 6 sample space. So 6 outcomes are there. In 6 outcomes, a prime number will appear. How many prime numbers are there? 2 is a prime number, 3 is a prime number, then 5 is a prime number. So total 2, 3, 5 are the prime numbers when a die is rolled. So we have 3 prime numbers out of total 6. So the answer to the first question is 3 by 6. Now question number 2 is a number greater than or equal to 3 will appear. Number greater than or equal to 3 means how many numbers are there? Greater than or equal to, it can be equal to 3 also. 3, 4, 5, 6, 4. 4 numbers are there, total number 6. Total sample space number is 6. Okay, 4 by 6, and it can be further simplified to 2 by 3. A number less than or equal to 1 will appear. Number less than or equal to 1, number less than or equal to 1, that is 1 only 1 is possible, one number is possible. 1 by 6 is the answer to third question. A number more than 6 will appear. More than 6, not more than or equal to, greater than or equal to. No, equal to is not there. So more than 6 will not appear because only 6 numbers are there. So 0, that means impossible event. 0 is the probability. Now question number 5, a number less than 6 will appear. A number less than 6, how many numbers are there which are less than 6? 5 numbers are there out of 6. So these are the answers. So we have finished 3 questions. Let me clear this. Okay. Okay, anyway, the next one is number 4. Number 4 is a card is selected from a pack of 52 cards. Okay, how many points are there in the sample space? A card is selected from a pack of 52 cards. So how many points are there in the sample space? Card means 52 different cards are there. So first answer is 52. Calculate the probability the card is an ace of spade. What is ace of spade? How many ace of spades are there? Spades means 13 spades are there, in which one is ace. So total 1 out of 52. That is the probability of the required probability of the second answer, second question. Now calculate probability that card is an ace. Card is an ace. How many ace cards are there? 4 ace cards are there. 4 ace card, total 52. That is the probability. Calculate the probability that card is an ace. So we answered that question. Black card, second one. The same question, second question is black card. Black card, total 26 cards are there out of 52. And it can be simplified to 1 by 2 as well. Question number 5. So we have so far finished 4 questions. Now question number 5. A fair coin with 1 marked on one face and 6 on the other, and a fair die are both tossed. A fair coin with 1 marked on one face and 6 on the other. A coin is there, and on that coin 1 is marked on one side and 6 is marked on one side. As regular, not head and tail. It is 1 and 6. And a fair die are both tossed. A fair coin and a fair die are both tossed. Find the probability that sum of the numbers that turn up is 3 and 12. Sum of the numbers is equal to 12. So what are the possible sample space? Sample space, first one, it can be 1 or 6. 1. Second is a die. So first coin, it can show 1, 2. And first one is the coin which shows head again, 1 again, and then 3. 1, 4, 1, 5, 1, 6. These are the, and the second coin, the coin may show 2 and die may show 1. 2, 1 can be one outcome, 2, 2 can be another outcome, 2, 3, 2, 4, 2, 5, 2, 6. Right? These are the outcomes. Not 2, 6 it was. 6, 6, 6, 6, 6, like this. And here you have to find out probability that the sum of numbers that turn up is 3. So how many numbers are there which gives a sum, which give a sum 3? 1, 2, only 1 is there. 1 divided by total number is 12. So that is the answer to the first question. Okay, 3. Now 12, how many times 12 comes? 12 is also coming only once. 6 6 when it is 6 6. Okay, if it is 7 1 6 and 6 1 will come. Okay. But if it is 12, only one possibility is there. So one possibility out of total 12. Now question number 6 is, there are 4 men and 6 women on the city council. 4 men. So 4 men and, let me choose another color. Okay. 4 men and, question number 6 we discuss, 4 men and 6 women. 6 women. Okay, 4 men and 6 women on the city council. If one council member is selected for a committee at random, how likely is it that it is a woman? So total number of men is 4 and number of women is equal to 6. Total number is equal to 10. Okay, and we have to choose a probability of a women member is selected. Probability of a women member is selected. So a women member, 6 women members are there, out of which we select 1, and the total C1, that is nothing but 6 by 10. If it is 2 women member, it should be 6C2 divided by 10C2. So that is what you have to remember. And question number 7, a fair coin is tossed 4 times and a person win rupees 1 for each head and lose 1.5 for each tail that turns up. Okay, tails up, turns up. From the sample space, calculate how many different amounts of money you can have after 4 tosses and the probability of having each of these amount. So that is a very important question, and we will solve it. See, a fair coin is tossed 4 times, so it will take a few minutes to complete that. See, H H H H H H H, you know, then H H H T. Okay, H H T H H T H H T H H H T H H. Okay, H H T H T H H. So H H T H H T H. Okay, this way you can bring it. Then H H T T H H T T H T T H T T H H T H T H. Like this way you can write. Okay, and the total 16 outcomes will be there. Total 16. So once again check it. H H H H is there. H H H T H H T H H H T T H T H H H T H T. Okay, S T T H T T H T T T H T H H T H T H T H T. Then what? T T H H. That is there. H T H T is there. H T H T. T H T H is also there. Okay. I think you have 5. and one more is T H H T, like that. 6 different types are there. Similarly, okay, that is there. Then T T T T T T H. Okay, T T T T H T, like this. T H T T H T T T. So similarly, it is also there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Last is T, 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 T. So this is full H. So total 16 are there. 16 outcomes. And here a fair coin is tossed. Tossed 4 times, and the person win rupees 1 for each head. Each head 1 rupee. So this is 4 rupees. Okay, 4 rupees. This is each head 3 and lose 1.5. So here it is. This is plus 3 minus 1.5. Okay, like that you have to write. 3 minus 1.5 equal to 3 minus 1.5. Okay, equal to 3 minus 1.5. And here 2 minus 3, because the price is decided like this: HH2 TT minus 1.5 2 times. So 2 minus 3 equal to 2 minus 3, 2 minus 3, 2 minus 3, 2 minus 3. And here H is 1. 1 minus 4.5, 1 minus 4.5, 1 minus 4.5. Okay, 1 minus 4.5, 1 minus 4.5. 4.5 means 3 T's. 3 into 1.5, 1 minus 4.5. Okay, so here answer is 4, and this is 1.5, 1.5, 1.5, 1.5, minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. So minus 1 is there. Okay, next is this 3 point minus 3.5, and this one is I made it wrong. So this is T minus 6. So this is so how many times he gains 4? So probability of getting an amount of 4 is only 1 by 16. Okay, probability of getting the amount 1.5 is 1.5 is 4 times 4 by 16. Probability of losing 1, how many times? There are chances 1, 2, 3, 4, 5, 6, 6, 6 times out of. So probability of losing 1 equal to 6 by 16, and probability of losing 3.5 rupees, that is probability of losing 3.5 is how many times? 4 by 16. And probability of losing minus 6 or losing 6, losing 6 means how many times? Once. 1 by 6, sorry, 1 by 16. So these are the probabilities, and this question is a very important question. Now the next question is yes, question number 8. 3 coins are tossed once. Find these probabilities. Let us very quickly, already we have seen such questions. H, H, H. 3 coins are tossed. H, H, T. And H, T, H. T, H, H. And T, T, T. T, H, T. H, T, T. And T, T, H. Okay. What is the probability? Total 8. So one by one, very 3 heads. Getting 3 heads. 3 heads how many times? Once out of 8. That is the answer. 2 heads. 2 heads 1, 2, 3 times. 3 by 8 is the answer to the second question. And at least 2 heads. At least 2 heads means what? Minimum 2 or more than 2. Minimum 2 heads or more than. So that is 4 times 4 by 8. And at most 2 heads. At most 2 heads means 0 heads, 1 head, 2 heads. Maximum 2 heads. Maximum 2 heads. 0 heads is also possible. 1, 2, 3, 4, 5, 6, 7. 7 by 8 is the answer. No head. No head means here you can see 1 by 8. 1 by 8. Only once it comes. No head. So that is 3 tails. 3 tails means only one. Again 1 by 8. Okay. Exactly 2 tails. Exactly 2 tails. Exactly 2 tails means exactly 2 tails. 2 tails only. 1, 2, 3. 3 by 8. No tail. No tail means when it comes once. No tail means once. 1 by 8. And at most 2 tails. Maximum 2 tails. Maximum 3 it cannot be. Maximum 3 tails means 7 times. 7 by 8. Because this is 0 tail. Maximum at most means maximum 2 tails are possible. It can be 1 tail also. 1, 2, 3. This will not come. Okay. So 7 by 8. This will come, this will come, this will come, this will come. Maximum at most means this can also come. I'm sorry. This will not come. Okay. So 0 tail, 1 tail, 1 tail, 1 tail, 2 tail, 2 tail, 2 tail, 3 tail will not come. Maximum 2 tails. So 7 times. Now question number 9. If 2 by 11 is the probability of an event, what is the probability of not A? If 2 by 11 is the event of probability of A, what is probability of not A? 9 by 11. 9 by 11 is the answer. That means from 1 you have to subtract 2 by 11. That is what we do. 1 minus probability of not A is equal to 1 minus probability of A. This is the formula which we are using here. 1 minus 2 by 11. That is equal to 11 minus 2 by 11. That is equal to 9 by 11. Okay. Now, a letter is chosen at random from the word assassination. Find the probability of the letter is a vowel. Assassination. Total how many elements are there? 13 letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total 13 letters are there. Out of probability of a vowel. Vowel, how many vowels are there? A, I, 3, 4, 5, 6 are there. Okay, so 6 by 13 is the probability of getting a vowel. And probability of getting a consonant means the remaining 7 by